Okay, guys, what I want to explore today is are some examples where you will get to use the power rule, but it's a little less obvious. By now, hopefully, you're pretty good whenever you are asked to take the derivative of something like, 2x to the fourth. Hopefully, you're pretty good at this now where you recognize that you have x raised to some nth power, which is what you're looking for when using the power rule. And just as a refresher, of course, this would turn into nx to the n minus 1th power, and that would be your slope equation for x to the nth. And so for this one, we could easily just bring the 4 out front and multiply it by the 2, and then reduce the exponent by a power of 1, and that would be our slope equation, or our derivative, of 2x to the 4th. But a lot of my students run into issues whenever it doesn't look exactly like this, and you may start to wonder, do I even get to use the power rule, or is there some magical, mysterious trick that I have to use instead? And I'm here to tell you that a lot of times you can use that same formula, but the trick is going to be rewriting first. You may have to do a rewrite on your problem. And so what's going to happen here is let's take an example, and then we're going to talk about how to rewrite that, and then we're going to actually get to evaluate it and use the power rule. So the first one that I'd like to talk about is a problem where you're asked, or sorry, you're given f of x is maybe something like 1 over x to the third power. Okay. And so you still see this x to the third, and maybe you feel like, oh, okay, well, I can just power rule the bottom and then leave it underneath the 1. And that's actually not going to fly, people. We got to be really careful here. But if you rewrite this to where it looks like it's some form of x to the n, then you are going to be in business, okay? So for our rewrite step, what I'm going to do is switch colors here. We're going to rewrite in yellow. So if f of x is 1 over x to the cube, you may remember your rules from, I don't know, the last 3 or 4 years of math life, that anything in the denominator you can write as not as a fraction, as long as you make the exponent negative. And so if you start by just taking that out of the denominator, now it is written as x to some nth power, and from here you can totally do a power rule on it. So the derivative of that, or f prime of x, would just be negative 3x, and then you need to subtract 1 from this, so be very careful. Negative 3 minus 1 would be negative 4, okay? And you don't want to leave your answer like that, so it's almost like you get to rewrite it again, right? So we're going to kind of take it back to the way it was written in the beginning, because we don't like negative exponents in math. So I'm going to write that as negative 3 in the numerator, and then x to the 4th, shooting to the bottom. And just like that, you get to use your power rule when maybe it was a little less obvious. The other example I want to show you is with square roots. So let's say, here's example number 2 here. We'll separate these. Okay, so let's pretend that you're given, like, I don't know, the cubed root of x to the 4th, something like that. Okay. So if you're given a problem like this that looks nothing like that, you might decide, oh, don't know how to do it. Maybe I'll use the limit definition of a derivative to figure it out, which you can, but it would be much less inconvenient than the power rule. So what you're going to want to do is the same thing. We're going to want to rewrite this, and this is another rule from algebra, where if you have a specific root of x to a specific power or a different power, then you can rewrite this as x to the b over a. So I want to keep this rule from algebra in mind, and my rewrite on this means that this f of x function is actually x to the 4/3 power, if you're sort of using this rule right here. That 4 is a little sloppy. There we go. X to the 4/3 power. And now it's, once again, you have an x or some variable raised to an nth numeric power. And even though it's a fraction, it's okay. We can still do a power rule. So, fun with fractions. We're going to find the derivative of this, which means the 4/3 moves to the front. Recopy my x. And then I need to take 4/3 and subtract 1. Okay? So if I'm going to subtract 1, I'm just going to kind of write it up here. If I subtract 1, remember that's the same thing as subtracting 3/3, right? And so that's just going to be a 1/3. And sometimes, guys, you can leave it like this in AP Cal. You know, it depends on your teacher, your professor, you know, whoever you're dealing with. I would be okay with you leaving it like this, but some people might not like it, and just in case, let's go do a rewrite back to the beginning and what it looked like. The 4/3 is just a 4/3, okay? So we're just going to recopy that. And instead of x to the 1/3, you could call that the third root of x to the invisible first power. That would be kind of working backwards from this little nice algebra trickery right here. So either answer is fine. Just talk with your teacher, professor. And these two can actually be joined together as well. You might end up having a square root problem underneath or in the denominator of a fraction, and then you'll have to undo that as well. So just quickly, I will shut up and give you one more example of something like that, where it's like, okay, now let's see if you can handle this, everybody. I'll just do like a fifth root, maybe like that. Okay, so if this is our function and we're asked to find, you know, f prime, then you're going to want to do your rewrite first, okay? So two things are going to happen. I'm going to think of this as x to the 1/5, but it's in the denominator. So whenever I bring it out here with the 2, the 2's in the numerator, so it just stays here. When I bring this up to the numerator, it'll be x to the -1/5. And that right there is just the rewrite, okay? And now we can use our power rule. So f prime is going to be -1/5, moves to the front. So -1/5 times 2 is -2/5. And then we have x to the -1/5 minus 1. Okay? Well, that's going to make for a lovely -6/5. And then right here, we do want to clean this up. This is pretty hideous looking, actually. So let's start by recopying our fraction, -2/5. And then with the 5, we're going to move the x down to the denominator since it's got a negative power. And I'm going to write that as the 5th root of x to the 6th. Because of that negative, it moves to the denominator. And then I just use my rule of radicals to exponents and vice versa. And that would be a lovely way to write your derivative. Happy power ruling!